In the circuit, values of node voltage V1 and V2 has been asked to find out, and these are the options. Let's see how find the values of V1 and V2 by using the KCL method. So in the given circuit, let's assume this is the node 1 and this is the node 2, and corresponding voltage is V1 and V2, and this is the earth, and this node is earth, its voltage value is 0. So to find out the voltage, let's apply the KCL at node 1 and let's see what equation we will get. So if we apply KCL at node 1, then we can see that at node 1 here is the V1 voltage, and in the KCL we know that if the current is incoming towards the node, then it is assumed as negative value, and if the current is outgoing from the node, then it is assumed to be positive magnitude value. So here, as we can see that we don't know what the direction in this 4 ohm, then we always assume that this voltage is at high voltage, and the voltage we have grounded, the node we have grounded has the 0 value. So current in this resistance will flow from V1 node to ground. Here 6 ampere current is coming towards node, 12 ampere current is coming towards this node, and in this voltage we don't know V1 and V2 which one is high, so assume that the current is flowing outwards from the node. Always if you don't know that the current will flow from towards inward or outward, then we always assume that the current will flow towards outward, and after analysis the magnitude of the current will show that the symbol of the current will show that what is in which direction the current is flowing. So here we assume that current is going towards outwards. So if we apply V1 at node 1, then what we see, this current 6 ampere, then minus 6 ampere. If we write the equation, then it will be as minus 6 ampere plus V1 by 4 ampere current minus 12 ampere, and plus V1 minus V2 upon 2 ampere current, and this is equal to 0. So this equation can be written as like this: V1 by 4, V1 minus V2 by 2 minus 6 minus 12 equal to 0. So here the equation will be 3V1 minus 2V2 equal to 18. That is, let's assume it is the equation number 1. As I have mentioned here that outgoing current is always assumed positive sign, and incoming current is always assumed negative sign with respect to node. Now let's assume at node 2 the voltage is V2. So what will be the equation at this node? Here 12 ampere current is towards outward, so we can write at as minus 12 ampere, and here we don't know what is the voltage of V2, so we always assume that the current will flow outwards. So here we can write as plus V2 by 5 ampere plus, here we don't know current will flow towards inwards or outward, then we always assume that current will flow in this 2 ohm resistance in outward direction from the node. Then this current in this resistance will be V2 minus V1 upon 2. So here it can be written as V2 minus V1 by 2 ohm plus current in this 10 ohm we don't know in which direction current will flow, so always assume that current is toward outward from the node, so it will be V2 by 10 ohm. The whole equation can be written like this. So if we readjust this equation, then we will find equation number 2 like this: V2 minus V1 by 2 plus V2 by 5 plus V2 by 10 plus 12 equal to 0, and after readjustment the equation will become minus 5V1 plus 8V2 equal to minus 120. Now we will solve this equation 1 and equation 2, then we will get V1 equal to 24 volt and V2 equal to 0 volt. So our final answer is V1 equal to 24 volt and V2 equal to 0 volt. Here V1 equal to 24 volt and V2 equal to 0 volt.